So all RFC traffic which emanates from that SAP system to the world outside, whether it's another SAP system or a non-SAP system, is going through that gateway work process, right? And you will see soon we will go through and list out, or maybe now is the right time to do it. We have in our content here. So DWeb Megs, right? The actual acronym itself is nothing but a acronym to make you remember all the work processes which SAP has. It does not really have all the work processes, but most of them, and I have kind of shown the ones it does not have down below, right? So D is the dialogue work process, the most common, which we can see here, right? DIA. The dialogue work process. This is the work process which is used for interactive workload. When you interact with SAP, you're using the dialogue work process, right? SAP GUI interaction. The most commonly used work process. Then you have the update work process, which updates the database. Right? So this work process has got only one activity, to update the database.
Update means, I mean, whatever the transaction, I mean, you know, we are committed to, right? Or it's going to update the message.
Just hold on for a second. I want to, my machine was not sharing. Sorry guys, this is the notepad document which I was showing. All right. Sorry, question again.
So what I was asking, I mean, this update message, I mean, is to update the data from application to the database, or the communication between database and...
No, it is to update the database.
So whatever I have saved at application level, so it will be of this process to
yes,
right. Get into the database.
Right. And why SAP is architected like that is my favorite interview question, and we'll cover this not today, in few sessions from today. Why SAP, why do the dialogue work processes not commit data to the database? Why does the update work process commit data to the database? And the answer to that lies in the fact that SAP does asynchronous updates. But why does it do asynchronous updates, and what's the benefit for an ERP system to do it? And even when it does asynchronous, it has got two levels of doing it at the asynchronous mechanism called UPD and UP2, primary and secondary updates. And you will see them in SM50 as UPD and UP2, right? And it's just different level of severity of those updates, primary and secondary, severity from a timing perspective. But SAP relies heavily on asynchronous updates. When I save a sales order and it states at the bottom, sales order number 1001 saved, at that point, Oracle SQL Server might have no idea that a sales order has been saved. It's all coming from the memory, saying that a sales order has been saved. Behind the scenes, the update work process is then going to commit that sales order asynchronously to the database. If SAP didn't do it this way, there is no way you could have an ERP system supporting 20, 30,000 concurrent users. You cannot guarantee that kind of performance unless you cache ahead of time your primary key data elements like the sales order number. And that whole concept in SAP is called number ranges. Number range concept is what's behind this. Again, advanced topic. For today, it's enough for you to realize the fact that asynchronous updates are done for performance reasons, and then there are two severities of it from a timing perspective, primary and secondary.
We can force our transaction to follow UPD or UP2, right?
If you are doing, only if you are doing a custom transaction. You cannot change SAP's behavior. It's a package application, right? So 80% of what SAP is doing is their own code. So you cannot force that code to behave any different without doing a core modification. If you do a core modification, you typically get a slap on your wrist, because when you upgrade SAP, you're going to run into issues. But if you build something custom in your Z namespace, then you can do whatever you want to do.
So it's the default behavior of SAP to follow, right?
Yeah. So it's primary and secondary. So essentially what it does is, primary is the core OLTP tables, and secondary is more statistical information, which even if it gets, the update gets delayed, it's not like some people are relying on it, right? But the core tables are going to get updated first, right? So if somebody says, okay, now I want to view sales order number 1001, right? And it's not even in the database, they won't be able to view it, right? But if somebody wants to say that, oh, I want to look at the total sales for today, the tables from where he or she is getting that information could wait for 2 seconds, 3 seconds, 5 seconds, right? So that's called SLS, Sales and Logistics Information System, right? So it'll wait for that, it'll do it later. So when we look at the architecture, and as a basis admin, that's what you need to appreciate, is the architecture of the system. Why did SAP spend time, effort, and money to architect it this way? Because once you understand that, that foundation will help you understand a lot of their other decisions. And performance is at the core of it. Is that they know that they have a very, very sophisticated lot of transactions, very database intensive application supporting tens and thousands of concurrent users, right? And they have thought about each and everything they do in and around that. E is for NQ. We talked about this a little while ago. This is the central lock handler. So all the locks are maintained in a database agnostic fashion in the NQ work process. All the locks in the system can be looked at by transaction SM12, which we are going to look at a little bit later, which shows you all the locks in the system. B is for the background process, right? So we see number of background processes here, or also called the batch work processes. This is to do background work, right? Batch scheduling, right? Things which need to happen not necessarily at night, but most of the time at night. But you could have a daytime batch as well. It is just that there is nobody sitting in front of it as an interactive user. It's being run by the system automatically, right, to do bulk workload. That's B for batch. Remote people, everyone is kind of quiet. Make sure you ask any question, if you have difficulty understanding what I'm doing. Yes, let me.
Yeah, this is Sachin Sharma. I just want to know how many gateway work processes are running. What is the command?
Yes, there is only one gateway work process running per instance, and the command to look at that is still PS minus EF, right? Or if you know upfront that the gateway work processes start with GWRD, you can actually do PS minus EF grep GWRD, And here's the gateway work process.
If I will give SAP work processes, then all these work processes, NQ and gateway, all come in that.
Yes. So if you just
one more thing, Ajay, how can we see the Java work processes and ABAP?
Yeah, so the Java, we have not talked about that yet. We are going to come to it. So when we come to it, I'll tell you. The ABAP side, as I told you, right, is that if you search for dwebmex 00, it will show you all of them, right? dwebmex 00 right here.
Okay, one more thing, Ajay. I just want to know that you told in the SAP system, SCM has two database.
Yeah, SCMs. S as in supply, C as in chain, M as in manager, SCM, where the previous name was APO, Advanced Planner and Optimizer. Yes, that is the only system which has got two databases. It has an OLTP database,
okay,
which all SAP systems have, which would be your traditional Oracle database or a SQL Server DB2 UDB. And it has an ODBMS, Object-Oriented Database Management System, called
why is that so?
Called Lifecache, which is used for, which is SAP's SAP DB database. The benefit of that ODBMS database is speed. What SAP and APO have to do is they need to do certain simulations to do demand planning, right? That's the business requirement, is to plan for demand, and they need to do certain simulations. Those simulations actually solve simultaneous linear regression equations. And to do, to solve those linear regression equations, you need a very fast computing power, all in real memory. And that's why it uses this object-oriented database management system. In the object-oriented database management system, you do not have rows and columns. Instead, you have got objects which you can design yourself. And those are, and instead of using SQL, which you would use in a traditional RDBMS, you use COM routines, component object model, COM routines, to go against these objects in a live cache. So primarily you're doing it for speed, and there are two orders of magnitude in a database system of speed difference. Right? So in a typical RDBMS system, things take 1 to 10 milliseconds to come back to you, right? If you do a normal SQL statement, 1 to 10 milliseconds, right? Things are in that range, if you do an index-based SQL statement. In a ODBMS system, the response time is typically in 10 to 100 microseconds. So you have got 100 order of magnitude difference in performance. And that is required in an APO/SCM system. And that's why that part of the functionality, which is called demand planning, is executed in live cache. All right?
Okay.
Sure. Okay. So, coming back to our notepad, so we did background. M is for message server. Message server